Hey everyone, and welcome back to WirelessPro. In this second part of our series, we're diving into how AI and machine learning are transforming beam management within 5G Advanced and 6G. Remember how 5G uses focused beams for amazing speeds? Well, AI is making those beams even smarter and more efficient. We'll explore the challenges of traditional beam management and how 3GPP is integrating AI to optimize connections. Get ready to see how intelligent algorithms predict and refine your signal for faster, more reliable mobile experiences. Let's dive in. Ever wonder how your 5G phone gets that blazing fast signal? It's all thanks to something called beam management. Imagine the cell tower, or TRP, and your phone, the UE, are both trying to find each other in a crowd. With P1, it's like the TRP is sweeping a super wide flashlight beam, trying to cover a big area to find you. At the same time, your phone is also trying out different listening angles to catch that signal. Both sides are doing a big, broad search to figure out the best way to connect. It's all about finding that initial strong handshake. Alright, so you're connected. But what if you move a little or there's some interference? That's where P2 comes in. P1 refers to processor 1 as defined in 3GPP standards. Think of P1 as finding the right street. Now with processor 2, or P2, we're trying to find the absolute best spot on that street. The TRP narrows its focus, refining its beams to a smaller area, and your phone adjusts its listening angles too. It's a more precise adjustment, keeping your connection strong and optimized without needing to do a full search all over again. It's all about keeping that signal super clear. Finally, we have processor 3. Here, the TRP is already sending a stable, strong beam right at you. It's found its target. But what if your phone moves slightly, or you shift how you're holding it? With P3, your phone gets smart. The TRP's beam stays the same, but your phone is internally adjusting its own receiving beams. It's like your phone is constantly wiggling its ears to perfectly catch that steady signal from the tower. Pretty cool, right? This ensures you always get the best reception, even when you're on the go. So beam management is key for 5G, but finding that perfect beam pair can be a challenge. Especially with super-fast millimeter wave signals, it means lots of searching and chatter on the network just to find the best connection. This is where 5G Advanced and 6G get exciting. They're bringing artificial intelligence, AI, and machine learning (ML) to make beam management way smarter and more efficient. Instead of constant searching, AI ML can predict the best beams. We're looking at two main ideas: spatial prediction, which is instantly guessing the best beams right now based on nearby signals, and temporal prediction, which uses past data to predict which beams will be best in the future. This means less searching, faster connections, and an even smoother 5G and future 6G experience for you. Now let's dive into how AI/ML actually predicts the best beams in 5G Advanced, starting with spatial domain beam prediction. Think of it this way. The AI/ML model learns from measurements of a set of beams we'll call set B. This set B acts like the AI's training data. It uses this data to predict the best beams within another set, called set A, in the current moment. We have two main scenarios here. One where set B uses SSB signals, and set A uses CSIRS, and another where set B is a subset of set A, both using CSIRS. You can see these different beam arrangements visualized in the grids on the left. The AI/ML model, shown in the middle, takes in signal strength measurements from set B beams as input. Its output, on the right, is a prediction of the top performing beams within set A. This allows the system to quickly choose the best beams for communication without exhaustively testing every single possibility. It's like the AI is saying, based on what I've seen, these are the best beams to use right now. Next up is temporal domain beam prediction. This takes AI/ML's predictive power to the next level. Instead of just looking at the current moment, the AI/ML model learns from historical beam measurements. It analyzes how beam performance has changed over time, typically with set B being included in or the same as set A. The AI/ML model, again in the middle, uses past signal strength measurements from set B beams as its input. But this time, its output, on the right, isn't just a prediction for now. It's a prediction of the best beams within set A for one or more future time instances. This is like the AI becoming a time traveler. It uses its knowledge of the past to anticipate how beam conditions will change and proactively select the best beams for optimal performance in the future. This significantly reduces the need for constant beam searching and ensures a consistently excellent connection, even as the environment changes. So how do these amazing AI/ML predictions actually happen? It's all thanks to different types of neural networks, which are essentially the, quote, brains of our AI models. Researchers in the industry are exploring various architectures to find the best fit for beam management. On this slide, you can see diagrams of 3 different neural network architectures we're actively studying. First, the Deep Neural Network, or DNN. This is a powerful, more straightforward architecture, showing great performance for spatial domain beam prediction, which allows for quick, immediate decisions. Next, the multi-layer LSTM, or Long Short-Term Memory Network. LSTMs are fantastic at remembering things over time, making them perfectly suited for temporal domain beam prediction, where the AI learns from historical data to predict future conditions. And finally, a more advanced and complex architecture, based on the UNet concept, including components like convolutional LSTMs and attention gates. This is something we're exploring for potentially even higher performance. So engineers are carefully selecting and designing these specialized AI brains to make your 5G and 6G experience as seamless and fast as possible. To make it crystal clear how AI/ML-based beam prediction works, let's see how it fits into the existing 5G beam management framework we've discussed, the P1, P2, and P3 procedures. As you can see in these figures, AI/ML isn't replacing these established procedures. Instead, it's enhancing them. The left figure shows how AI/ML-based beam prediction can be integrated at the network side. The G-Node B uses AI/ML to predict optimal beams for downlink transmission, making P1, P2, and P3 more efficient. Similarly, the right figure shows how AI/ML can be used at the UE or your phone side. The UE leverages AI/ML to predict the best received beams, again streamlining the P1, P2, and P3 processes. By integrating AI/ML into both the G-Node B and the UE, we create a smarter, faster, and more robust beam management system. It's about making the existing framework even better with the power of artificial intelligence. We've covered the fascinating theory behind 5G advanced beam management and how AI/ML is transforming it. But how do we actually test and prove these cutting-edge ideas? That's where simulations come in, and we're thrilled to introduce our new software, WirelessPro, written in Python, designed specifically for this research. On this page, you're seeing a glimpse of WirelessPro in action. In the background, you can see a Visual Studio Code environment where we've opened a project focused on temporal beam management that's predicting future beams. You can also see the Python code files in the workspace, covering everything from generating data to training our AI models and testing them in simulations. The dynamic image on the right illustrates the P1, P2, and P3 procedures playing out, representing the processes we can simulate and analyze. And on the bottom left, that table displays real simulated L1 RSRP measurements that WirelessPro helps us generate and process. WirelessPro is a powerful tool for this research, providing the flexible environment needed to validate our AI models and bring the theoretical concepts of AI/ML-based beam management to life, pushing the boundaries of 5G advanced and 6G development. So there you have it. We've seen how AI and machine learning are revolutionizing 5G advanced beam management. By making beams smarter and more efficient, AI is tackling the complexities of current systems and predicting optimal connections in both space and time. This means your 5G and future 6G experience will be even faster, more reliable, and seamless. What are your thoughts on AI powering our wireless world? Let me know in the comments below. And if you enjoyed this deep dive, don't forget to install and try WirelessPro for more insights into advanced wireless technology.